Example 2. Solve the inequality 5 over x minus 2 times x plus 3 is greater than 0. So if you recall, to solve a rational inequality, what we need to do is find out where the numerator is equal to 0 and where the denominator is equal to 0. But in this particular example, the numerator does not contain an x. So even if we set, the numerator equal to 0, that will give us 5 is equal to 0, and 5 is never equal to 0. So there are no zeros of this function. We also need to figure out where the function is undefined. Those are other critical values. That's where the denominator is equal to 0. So that gives us x minus 2 times x plus 3 equals 0. And since this one is already factored, we're just going to take those factors and set them equal to 0. So this one gives us x equals 2, and this one would give us x equals negative 3. So what we're going to do with those values is we are going to put them, we're going to treat this top line of this table as a number line. And we'll put the first critical value here and the second critical value here. So negative 3 would be the smaller of those two, and then 2 will go here. Then we'll put our factors. So we have x minus 2. We have x plus 3. Then for this row, this will be for the sign of the whole function. And then we're going to add another row to our table. I think I forgot a row here, so we'll just add one. And this will tell us whether it satisfies the inequality, which is greater than 0. So remember, what we're going to do is we're going to pick test values in each of these 3 regions. So a test value below negative 3, a test value between negative 3 and 2, and a test value greater than 2. And what we want to do with that is plug it in the function, determine the sign of the function, and then see if it satisfies the inequality. And in this case, the inequality is that y has to be greater than 0. So that means we're looking for values of x that make the function positive. So if it's greater than 0, we're looking for where the function is positive. If it's less than 0, like it was up here, we were looking for where the function is negative. And that's what we mean in our instructions up here. Determine the sign of the function on the intervals defined by the boundary points. If f of x is positive, then the values of x on that interval are solutions to the inequality f of x is greater than 0. And if f of x is negative, it satisfies the inequality f of x is less than 0. All right, so back to our problem. So if I pick a number less than negative 3, I'm just going to choose negative 4. If I plug negative 4 into these inequalities, I'm going to get negative 4 minus 2, which is negative 6. And really, we're just concerned with the sign. It doesn't really matter what the number is. If I plug negative 4 into this inequality, I'll have negative 4 plus 3, which is negative 1, which again is negative. So now if we look at the function itself, the top will always be positive. So we just have to determine what the sign of the denominator will be. So a negative times a negative will be positive. And of course, a positive divided by a positive is going to give you a positive answer. So remember, we are looking for where the function is positive, and since it's positive here, the values of x satisfy this inequality, so the numbers in this interval are going to be a part of the solution. Now let's move to the second interval. So 0 is a number in this second interval. So if 0 is in that interval, I use 0. If I plug it in here, I will get 0 minus 2, which is negative 2, which would be negative. 0 plus 3 is positive 3, which would be positive. And a negative times a positive is going to be negative. So remember again, we're looking for where the function is positive, and since the function is negative in this interval, then I would say that no, the numbers in this interval do not satisfy the inequality, so this would not be a solution. Finally, we move to the third interval. That would be numbers greater than 2, so I'm going to choose 3. If I plug 3 in there, I'm going to get 1, which is positive, 6, which is also positive because 3 plus 3 is 6, and a positive times a positive will give me a positive. And so since my inequality is greater than 0, I would say the x values in this interval satisfy that inequality. So my solutions are this interval, which would be from negative infinity up to negative 3, and this interval, which would be from 2 to infinity. The last thing I have to decide is whether I would put brackets or parentheses here. Since there's no equals to, I would put parentheses. However, even if there was an equals to, remember that with rational inequalities, you have the added problem that your boundary numbers could make the denominator 0. And since both of these numbers, negative 3 and 2, came from making the denominator 0, I would still use parentheses here because we couldn't use negative 3 or 2. So don't forget that when you're solving rational inequalities. So the solution to this inequality would be the numbers from negative infinity up to negative 3 and the x values from 2 to infinity.